Good day, mathematicians. We are going to be going over your Chapter 12 Assessment Study Guide, and the chapter was on geometry. And let's get started. Question number 1 through 6. The directions ask us to choose the most precise classification for each figure. So each figure may have many names. What is the most precise name? So for example, this figure right here is a polygon, it's a parallelogram, it's a quadrilateral, it is a rectangle, it is a rhombus, but the most precise name for it would be a square. So while it is a rectangle, a better name for this is a square because all of the sides are the same length. And a rectangle would just be a shape with 4 sides and a parallelogram with 4 sides, and those 4 sides would have 90-degree angles. Okay, next, question number 2. We have a triangle here. And if you notice that there are 2 X's, this is letting you know that the left side and the right side are equal in length. And that would make sense because this angle and this angle are also the same measure. This is an isosceles triangle. A scalene triangle, no sides are the same length. An equilateral triangle, all the sides are the same length. Next, question number 3. A parallelogram has 2 sets of parallel sides. Now this is the symbol for parallel, 2 slanted lines. A trapezoid only has 1 set of parallel sides. In this case, my top base and my bottom base are parallel. So this would be a trapezoid. If I were to continue the left side going up and the right side going up, they would eventually meet, and therefore they are not parallel. Question number 4. This is a 3-dimensional object. It is a rectangular prism. It is not a cube. A cube would have to have all of the sides the same length. And in this case, the length here is longer than the width or the height. So that makes it a rectangular prism. Question number 5. We have a triangle here. It's asking whether it is a right triangle or an acute triangle. Every triangle has 2 acute angles. It's the 3rd angle that gives it its name. This box lets me know that this is a 90-degree angle, which means it is a right angle, and therefore a right triangle. An acute triangle may look something like this, where every angle is acute. If you ever have to draw an obtuse triangle, I would draw your base. Then, very lightly, you want to draw a 90-degree angle, and you know that an obtuse angle is larger than 90 degrees, so you're going to open this up larger than or past your 90-degree mark. Then all you have to do is connect the 2 lines. So this would be obtuse, this would be acute, this would be acute. So that would be an obtuse triangle. And it does look like my next question is asking me to draw an acute triangle, which I did right over here, but we can do it again. Every angle is acute. Acute, acute, acute. Every angle is less than 90 degrees. Question number 7. Find the volume. Show your work. Be sure to include units in your answer. Oh, look at that, guys. Units in your answer. All right. Now, volume. We know that volume is the area of the base times the height. This is area of the base. In this case, the shape of the base is a rectangle. So that would be length times width. So we could do length times width. So I'm going to make this length. This will be width. And this will be height times height. So this would be... So we have volume equals 6 centimeters times 3 centimeters times 4 centimeters. So volume equals 6 times 3 is 18. And when I multiply centimeters times centimeters, I get centimeters squared, because that's the area of the base, and area is a squared unit, times 4 centimeters. So volume equals, and we're going to get, I'm going to write this right down here, 72 centimeters cubed, because centimeters squared times centimeters is centimeters cubed. And 3 here means 3 dimensions, and those dimensions are length, width, height. So that's why we have the 3 there. Question number 8. All of the cubes in the tower are the same size. What is the volume of the tower? Okay, so let's see how many cubes we have. We have 1, 2, 3, 4, 5, and there must be one back here, 6. Because if there wasn't a 6th one back here, these 2 would not be able to be standing. They'd fall down. So there has to be a total of 6 cubes. We're going to find the measurement of the volume of 1 cube and then multiply it times 6 so that we can get the volume for the whole set of cubes. Now volume equals length times width times height. So volume is going to equal 4 centimeters times 4 centimeters times 3 centimeters. Volume is going to equal 4 times 4 is 16. Centimeters times centimeters is centimeters squared times 3 centimeters. So volume equals 48 centimeters cubed. Now that's the volume for just this one block. We have 6 blocks or 6 cubes, so we're going to do 48 centimeters cubed times 6. These are 6 blocks, and we get 28 centimeters cubed. Question number 9. Kelly is shipping boxes of hiking boots to the shoe store. At the bottom of each shipping box, she can fit 6 shoe boxes. If the shipping box is filled with 5 layers of shoe boxes, how many shoe boxes can she fit into the shipping box? This sounds like a tongue twister. All right, so let's see what we've got here. Kelly is shipping boxes of hiking boots to the store. Okay, we got that. At the bottom of each shipping box, she can fit 6 shoe boxes. All right, so we've got it. She has a shipping box. So let's draw a shipping box. And at the bottom, there's 6 shoe boxes. So I'm going to have to go like this. Okay, so we have 1, or there's boxes 1, 2, 3, 4, 5, 6. So there's 6 boxes there. Okay, so there's 6. 6. If the shipping box is filled with 5 layers of shoe boxes, so we've got layer 1, layer 2, layer 3, layer 4, layer 5. Okay, and in each layer there's 6. So 6, 6, 6, 6, and 6. Okay. How many shoe boxes can she fit into the shipping box? So we would do 5 layers times 6 boxes per layer equals 30 boxes. There are 30 shoe boxes in the shipping box. Question number 10. Matt bought fertilizer for the lawn in 2 different sizes. The smaller package of fertilizer measured 10 inches by 13 inches by 3 inches, and the larger package of fertilizer measured 14 inches by 22 inches by 5 inches. What is the difference in the amount of space taken up by the 2 fertilizer packages? So we're going from shoe boxes to fertilizer. All right, so he buys fertilizer, 2 different sizes. There's a smaller size and a larger size. So I'm going to draw my smaller box and my bigger box. Now the smaller package is going to be 10 inches. Now you can use a dot for multiplication. I'm going to use a dot. 18 inches times 3 inches. And the larger package, the volume would be 14 inches times 22 inches times 5 inches. So again, these dots can represent multiplication. And real quick, you can represent multiplication with an X, a dot, parentheses, or an asterisk. They all mean to multiply. All right, so let's find the volume of the smaller package. I'm going to multiply 10 times 3, so I get 30 inches squared times 18 inches. So the volume equals 540 inches cubed. Here, I'm going to multiply 22 times 5, because I can do that in my head, and that equals 110 inches squared times 14 inches. Okay, so 110 inches squared times 14 equals 1,540 inches cubed. The question's asking us what is the difference in the amount of space taken up by the 2 fertilizer packages. Well, difference means I need to subtract. So 1,540 inches cubed, subtract 540, 0,001 inches cubed, the larger packet of fertilizer takes up 1,000 inches cubed more space. Levi is building 3 bookshelves. Each bookshelf is 3 feet tall, 4.5 feet long, and 1 foot wide. What is their total volume? So he has 3 bookshelves, and I'm going to draw them. And I do think drawing helps. So the volume of one of the bookshelves would be 3 feet times 4.5 feet times 1 foot. You can choose to write this as a fraction or a decimal. Since it's half, it's easy to change to a decimal. So I'm going to do 1 times 4.5, so volume equals 3 feet times 4.5 feet squared. So we have 4.5 feet squared times 3, 13.5 feet cubed. Now that's for one of these. So every one of these is that amount. So we're going to do 13.5 feet cubed times 3 shelves. 15, 10, 4 feet cubed. So you should get 40.5 feet cubed. Their total volume of the 3 bookshelves is 40.5 feet squared, or the total volume of the 3 bookshelves is 40.5 feet cubed. Question number 12. All right, now for question number 12, it says describe the faces, edges, and vertices of the 3-dimensional figure shown below. You're going to have to decide, and you can go with 2 different answers here. It is definitely a pyramid because it comes to a point. Now, is it a square pyramid or is it a triangular pyramid? You're going to have to decide because we can only see these 3 points. There could be a point in the back to make it a square pyramid, or it could just be a triangular pyramid. So answers can vary on this question. You just need to defend yourself. All right? So I'm going to give you the answers to both. All right? So let's start off with it being a square pyramid. So if it's a square pyramid, I'm actually going to draw a square pyramid here. And it's asking for faces. So I would say this 3-dimensional figure has 5 faces, 8 edges, 5 vertices. So 5 faces, the triangles are 1, 2, 3, 4, and then the base is a rectangle. So it would be 1, 2, 3, 4 triangles, and then a base that's a square. The edges, 1, 2, 3, 4, 5, 6, 7, 8. And the vertices, so I'll just go 1, 2, 3, 4, 5, 6, 7, 8. The vertices, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Because it comes to a point. Let's say that you decided that this was not a square pyramid, but rather a did I say triangular prism? A triangular pyramid. I hope I said that. Triangular pyramid. I hope I said pyramid. So triangular pyramid would look like this. Triangle, dot, okay. So this 3-dimensional figure has, okay, so it has a triangle, triangle, triangle for the sides coming up, okay? The sides coming up. And the base is a triangle. So that's four faces. And the edges, 1, 2, 3, 4, 5, 6. 6 edges. And points or vertices, 1, 2, 3, 4. 4 vertices. 4. Question 13. A grocery store is stacking cans of food into a triangular display. The bottom layer has 20 cans. There are 7 layers. If there are 3 fewer cans in each layer, how many cans are there in the display? Draw a diagram. All right, so we know that a grocery store is stacking cans of food into a triangular display. So you know one of those displays that kind of like goes like this at a grocery store, okay? So it's 7 layers. So we're just gonna have to draw a little diagram here. And we're gonna go up 1, 2, 3, 4, 5, 6, 7. And then we're going to go down. 1, 2, 3. So we have 7 layers. 1, 2, 3, 4, 5, 6, 7. The bottom layer has 20 cans. And there are 3 few cans in each layer as you go up. All right, so we're going to subtract 3. That gives us 17. Subtract 3 gives us 14. Subtract 3 gives us 11. Subtract 3 gives us 8. Subtract 3 gives us 5. Subtract 3 gives us 2. So we have 20 cans, 17 cans, 14 cans, 11 cans, 8 cans, 5 cans, and 2 cans, because it says how many cans are in the display in all. So we're going to have to add these up. And we have 77 cans in the display in all. Based on your diagram and your answer above, write an equation that represents the total number of cans in the display. All right. Now, this is complicated. You're thinking, okay, what do I do? When it gets complicated, the best way to do this is to make an in-out box, just like you did when you were in elementary school. In, out. Now your in is going to be the layer number, and the out is going to be the number of cans. So we have 7 layers, so we're going to go 1, 2, 3, 4, 5, 6, 7. And we're going to see if we can come up with some kind of pattern here and change that pattern into an equation. So layer 1, let's say is the top, has 2 cans in it. Layer 2 has 5. Layer 3 has 8. Layer 4, 11, 14, 17, and 20. Okay, so we know that this is plus 3, plus 3, plus 3, plus 3, plus 3. So we know that that's plus 3 this way. But for an equation, we need to know, how do I get from the layer number to the number of cans? How could I get from this number to this number? This number to this number? There has to be a consistent way to get from the in to the out. Now, you might want to pause the video and think about it, but this is what it would be, all right? If I do 1 times 3, take away 1, I get 2. If I do 2 times 3, take away 1, I get 5, because that's 2 times 3 is 6, take away 1 is 5. 5. All right, so the layer is 3 times 3, take away 1 equals, that's 9, take away 1 equals 8. So what am I doing here? I'm taking the number of the layer times 3, take away 1 equals the number of cans in that layer. Okay, so the layer number here is 4 times 3, take away 1 will give me the number of cans. So that's 12, take away 1 equals 11. Sorry, getting rid of 11, sorry. And then 5 times 3 is 15, take away 1 is 14. Layer 6 times 3 is 18, take away 1 equals 17, so there's 17 cans there. Layer 7 times 3 is 21, take away 1 equals 20 cans. So it would be the layer number times 3, take away 1 equals the number of cans. All right, now, here's a tricky thing, okay? 14a. Courtney and her little sister built a tower on the floor out of 4-inch cubes. They were able to stack 8 cubes, one on top of the other. If Courtney walks all the way around the tower to look at it, how many of the cube's faces will she see? Draw a diagram. All right, so if you can imagine, we have a tower here built, and we have a little girl named Courtney walking around the tower. Okay, so as she walks around this tower, she is going to be able to see the front of the tower, the right side of the tower, the back of the tower, and then the left side of the tower. And we know that there are 8 cubes that are stacked to make the tower. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They mention here that these cubes are 4-inch cubes. Well, if there are 8 cubes, that means that the tower is 4 inches times 8, 32 inches tall. Now, 32 inches tall is shorter than a yardstick. A yardstick is 36 inches long, and the height of a countertop would be approximately the size of a yardstick, and your desk is about 30 inches off the ground. Also in this problem, it says that it's Courtney and her little sister. So we're noting here that Courtney is a bigger sister. So if Courtney is taller than 32 inches, she's going to be able to see the top of this tower as well. So I'm going to assume that Courtney is taller than 32 inches. So she's going to be able to see the top. Now she can't see the bottom because the bottom is actually on the ground. Okay, so she can see 8 faces in the front, 8 faces on the right, 8 faces in the back, and 8 faces on the left, and 1 face on the top for a total of 32, 33. 33 faces in all. We're supposed to write an explanation for this, so I will write, I know that each cube has 4 sides because they are stacked, comma, you will see only the sides and not the top and bottom, comma, except for the top cube. 4 times 8 equals 32 plus 1 top side equals 33 faces. Based on your diagram and your explanation, write an equation that represents the number of faces Courtney will see. So the number of cubes times 4, because there's a front, back, left, right, plus 1, because the uppermost cube, you'll be able to see the top, okay, equals the number of faces you will see. So in our case, it was 8 times 4 plus 1 equals 33 faces. So this was cubes, sides, top. Alrighty then, moving on. Multiple choice. Choose the correct answer. Which three-dimensional figure has 6 faces, 12 edges, and 8 vertices? Well, that would be a rectangular prism, and that would look something like this. What type of triangle is shown here? All the sides are different lengths. That's scalene. Isosceles triangles two sides are the same length and one side is different. A right triangle has a 90-degree angle. This one does not have 90 degrees. An equilateral triangle, all the sides are the same length. Moving on. Heather stacks 7 rectangular prisms on top of each other. If each prism is 3 inches by 2 inches by 5 inches, what is the volume of the composite figure she created? So we have 7, 1, 2, 3, 4, 5, 6, 7. And 1 cube is 3 inches by 2 inches by 5 inches. So 3 inches times 10 inches squared. So the volume equals 30 inches cubed. So that's 30, 30, 30, 30, 30, 30, 30, or 30 inches cubed times 7, 0.21. Now, you'll see that there's 2 answers that have the number 210 in them, and the correct answer is inches cubed. This would be area, like tiles on the floor, and this would be cubes. Perry draws a large rectangular octagon on the smartboard. If the perimeter of the octagon is 72 inches, what is the length of each side? Okay, so an octagon, like an octopus, is 8-sided. And that is the shape of a stop sign. 1, 2, 3, 4, 5, 6, 7, 8. And we want to divide 72 inches between the 8 sides. And to do that, we'd have 9 plus 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 9, because 9 times 8 equals 72. So each side is 9 inches long. All right, kids, there you have it. Hopefully you do super great on your quiz, and I wish you the best of luck. Bye-bye.